Hello everybody and welcome back to another math learning video. Today I brought you guys this problem here. X factorial is equal to x cubed minus x. And what we are tasked with doing is we need to solve for x so that this statement becomes true. Okay? So let's go ahead and get started. So we have two sides in our equation here. X factorial is equal to x cubed minus x. And as you can see, both sides have an x in them, so we have multiple occurrences of the variable x, so we can't simply just put x on one side and all that. So what we're going to do first is we're going to kind of rewrite this problem a little. So let's start with the right side. So x cubed minus x. So already we can notice here there are two terms here that are being subtracted by one another, and both of these terms have the x in them. So since both terms have an x in them, this means that we can factor out an x from both of them. So factoring out means I just simply take one away and I'll just multiply it here on the outside. And then in the inside of the parentheses, we'll have this equation, x cubed minus x, with one x taken away. So we take an x away from both terms. So if we take away from an x from x cubed, that simply leaves us with the x squared, because x cubed is x times x times x. So now we only have x times x. And then if we take away an x from x, that leaves us with 1. And you can double check this if you want to by multiplying x on the outside by x squared minus 1. We should get the original thing. And the left side, I'll just keep as is for now. And now, on the right side, so in this parentheses, x squared minus 1, if both of these values were to be squared, we can use the binomial formula to expand our expression here. You may be thinking, oh, there is not two values being squared, because it has to be one thing I'm thinking about looks like this, a squared minus b squared, and then this could be expanded into a minus b times a plus b. So this is the formula, binomial formula. So this is equal to this. And we could do this if our a would be x, but our b needs to be squared, which at the current moment it's not squared, but if you think about it, 1 squared is equal to 1, right? So instead of 1 that is written here, minus 1, we could write 1 squared, and it would not make a difference because 1 squared is equal to 1, so this equation still stays the exact same. So now with this, if we have our 1 squared, this means that our b can be written as 1, since they both are squared here. So now we simply, on the right side, in this parentheses, we can change from x squared minus 1 squared into this a minus b times a plus b, where a is equal to x. So it'll be a minus b, x minus 1, because our b is equal to 1, and then a plus b, which is x plus 1. Okay? So now we have our new kind of right side. We kind of factored it out. But where does this help us? Well, now let's go and take a look at the left side. So what do we have here? X factorial. So what does x factorial actually mean? Well, this means that for whatever value, for example, for 4 factorial, for example, this is going to be equal to the value in front times all the whole number integers that come between this number and 0, and 0 not included, of course. So 4 factorial would be 4 times 3 times 2 times 1. So you always go until 1. Then 5 factorial is 5 times 4 times 3 times 2 times 1, and so on, right? So our x factorial, is there a way that we can write this out? Well, we don't know what our x is, right? So we don't really know how many times we have to write it, but the format that it should be would look like this. X, right? Since x is the first value that we have, times x minus 1 times x minus 2, and so on, so on, so on, until you have the final values of 3 times 2 times 1, because it always ends in 3 times 2 times 1 here. So this is kind of what the format looks like. Of course, it always depends on how many values there are, or how big your x value is. The bigger your x is, the more integers you have to multiply. So this is kind of just a blueprint for it. But it can help us, because if we look at how we have rewritten this x factorial, you will notice that this x and x minus 1 also appears in this part here on the right side of our equation that was factored. So it might be actually be useful to use this x factorial in this rewritten form. So now when I rewrite my equation for the left side, instead of having x factorial, I'm going to rewrite this as x times x minus 1 times. So now here comes the dilemma where I cannot just infinitely write x minus 2, then x minus 3 until I get to the 3, 2, 1, because I don't know how many numbers I need. So the only way that we can rewrite this when we're not sure how many numbers we have is by using a factorial again. And if you notice, at this x minus 2, the numbers keep going down until it reaches 1, right? So, and now we can write this part of the x factorial as x minus 2 factorial. Because if you think about it, this is simply just going to be x minus 2 times x minus 3 times x minus 4. So this is basically starting at x minus 2, you keep on multiplying by minus 1 of that until you reach 1. So it's x minus 2 factorial. So now this is how we have rewritten our x factorial. And now let's just add onto the other side what we have on the right side. So how we factor this part, which is x times x minus 1 times x plus 1. Okay, so now we have rewritten our original equation to look like this. So now we have rewritten the equation to look like this, with our x factorial on the left side looking like this, and our x cubed minus x on the right side looking like this. And now we already noticed that on both sides we have an x on both sides, so that means that we can divide by x on both sides, which in the end just cancels these two out, right? And always when you divide by a variable, you need to make sure that the value is not 0. So in this case, x cannot be 0, right? Because if you divide by 0, a lot of funky stuff starts to happen. So in this case, we have to make sure that 0 is not a a legitimate answer for our problem, because then we'd be skipping over it because we can't divide by 0. So to check that, we simply just plug in 0 real quick. So you get 0 factorial. And so now here is kind of a weird rule. 0 factorial is equal to 1, okay? And then on the right side, we have 0, everything 0, 0 minus 0 is equal to 0. So the end, we'll get 1 is equal to 0, which is not true. So this means that 0 is not anyways a feasible answer for our equation, so we don't have to worry. So we can simply divide by x without worrying. And now we have x minus 1 times x minus 2 factorial is equal to x minus 1 times x plus 1. And you've already might have noticed this, but like last time, we have similar terms on both sides. So this x minus 1 is being multiplied on both sides. So we can just divide it by x minus 1. And again, we got to make sure that when x equals 1, it means we'd be dividing by 0. So we just need to make sure that when x is equal to 1 here, that we need to check if this is a feasible answer for our equation. So 1 factorial is equal to 1. and then anything, 1 to the power of anything is 1 minus 1. So 1 is equal to 1 minus 1 is equal to means 1 is equal to 0, which is not true. So once again, 1 is not a feasible answer for our equation, so we don't need to worry. So we can divide by 0 here in this case. Sorry, not we can divide by 0, but we can divide knowing that x will not equal 1, so we will not have to end up dividing by 0. That's what I meant to say. So this leaves us with everything canceled out. X minus 2 factorial is equal to x plus 1. So now, how do we check what can this be? Well, and how do we know how many answers there will be? Well, let's think about it. Let's think about it from a graph point of view. X plus 1, there's actually no need for the parentheses anymore, so I'll just remove them. X plus 1, think about it on a graph. X is not squared or not anything, so this will just be a linear graph with a straight line. It'll just keep on having constant slope like that forever. And x minus 2, on the other hand, is a factorial, which means that factorials, always when you increase x by 1, you always multiply basically that number to it, a new number to it. So which means that with each x that gets, as x gets bigger, the y also gets substantially bigger than x, where when x gets bigger, the y gets bigger on a constant rate. So this means that they will only meet up one time at one point. And to find this point, there are various methods with how we can find this point where they meet up, but I'll just be graphing this. So now here I have brought a graph and a table, where in the table we have a certain list of x values. So what we're going to plug in into the two equations here, because these equations come from our equation in the beginning, where we stated that they're equal to each other. So we want to find when they are equal to each other. So this means that when we plug in the x value to the equations, we need to find at which x value we get the same y value. And the y value is the answer you get when you plug it in, okay? And we're just going to graph it. Although you don't need to graph it, it can help you visualize it, okay? So first thing, our x value of 1 for x minus 2 factorial. So we plug in 1 here, and then we get 1 minus 2 factorial, which gives you negative 1 factorial. And negative 1 factorial as a negative number as a factorial is a little complicated, so we'll just we just won't worry about that right now, because if we plug in 1 to the next equation, it obviously will not be negative 1 factorial, because when we put 1 into the next equation, it's equal to 2, right? 1 plus 1 is equal to 2. So if we plug in, so now if we plot these equations onto the graph, we get that for our green. Our green is our second equation, so I color coded them. So for x equals 1, at green we have a 2. So now for x equals 2, when we plug it into the first equation, we get 2 minus 2 factorial, which is 0 factorial, right? And as I stated before, 0 factorial is equal to 1. And then for our green equation, 2, plug in for x, 2 plus 1 is equal to 3. So now let's graph this. So on the red, we have x equals 2, y is equal to 1. And then for our green, we have x is equal to 2, y is equal to 3. All right, and now for x is equal to 3, when we plug in 3 into the red equation, we get 3 minus 2 is equal to 1. 1 factorial is simply 1, because you just multiply 1. And then plug in 3, 3 plus 1 is equal to 4. So now we have our x equals to 3, y is equal to 1 for the red equation. Then for the green equation, we have x is equal to 3, y is equal to 4. So now for x is equal to 4, when we plug in 4 into the red equation, we get 4 minus 2, which is 2 factorial. And 2 factorial is equal to 2 times 1, which gives us 2. And then we plug into the green equation, 4 for x. 4 plus 1 is equal to 5. So now when we graph this for the red equation, we have 4, 2, and then for the green equation, we have 4, comma 5. And now for x is equal to 5, when we plug in 5 for the red equation, we get 5 minus 2 is equal to 3. So 3 factorial, is equal to 3 times 2 times 1, which is equal to 6, right? And then for the green equation, when we plug in 5 for x, we get 5 plus 1, which is also 6. So here you already notice that they have the same y value. So if we look on the graph, it'll look like this. They both meet up at 6, so the red will be 6 is about here, red is here, and green is here. So that means that when we draw the lines, this graph goes like this, and the green graph goes like this. Okay? So then they meet up at x equals 5. So that is the main important thing for our problem. We found that these two equations meet up at x equals 5. So that means that our final answer to solve for x is that x is equal to 5. Of course, you do not need to graph this problem in order to solve it. I just graphed it in order to kind of visualize how the equations grow. Because you can see that in the beginning, the red equation, the factorial, started off kind of small, but then it grew very big in a short amount of time as compared to the green equation, which grew at the same rate constantly. So in the end, if you have an equation like the red one that keeps on growing exponentially or as a factorial that does not have the same slope all the time, it will eventually overpass the an equation which is just constant, like x plus 1. So yes, our final answer is equal to x is 5. And that is it for today. So thank you guys for watching this video. I hope you guys enjoyed it and see you guys next time. Bye.